Let us discuss all the questions in the test. The first one, alpha and beta are solutions of this equation, and we have to find value of tan of alpha plus beta. We have to prove this is 2ac upon a square minus c square. Now what is tan of alpha plus beta? This is tan alpha plus tan beta upon 1 minus tan alpha into tan beta. Tan alpha plus tan beta, this is sum of roots of this equation, and tan alpha into tan beta, that is product. So let us use this equation, b secant of x, this is c minus a tan of x, squaring both sides, secant square of x, this is c square plus a square tan square of x, and minus 2ac into tan of x. We have kept secant x on one side and constant term and tan x this on other side. Secant square of x is 1 plus tan square of x. This is c square plus a square tan square of x minus 2ac into tan of x. b square, this is tan square of x, and this is equal to a square tan square of x minus 2ac tan x and plus c square. Shifting all the terms to the right hand side, this is a square minus b square into tan square of x minus 2ac into tan x and plus c square minus b square. This is, can we say, in the next one we have to find out value of tan of 2a. This is compound angle 2a. This can be written as this plus this, a plus b plus a minus b. These are constituent angles. Taking tan on both sides, tan 2a is equal to tan of, it's a plus b first angle and plus a minus b second angle, which is tan of first angle a minus a plus b plus tan of second angle a minus b upon, it's 1 minus tan of first angle a plus b into tan of second angle a minus b. Substituting values, tan a plus b is x, this is y, this is 1 minus x into y. Similarly, we can write tan of 2b in terms of constituent angles a plus b and a minus b. This is a plus b minus a minus b. Taking tan on both sides, tan 2b, this is equal to tan of a plus b minus tan of a minus b upon 1 plus tan a plus b into tan a minus b. Substituting values, this is x minus y, this is 1 plus x into y. We have to convert this expression to sign only. So first step is that we divide throughout by square root of coefficient of sin x root 3 square and plus coefficient of cos x, that is minus 1 square under the root. This is 2. So this can be written 2 into root 3 by 2 into sin of x minus 1 by 2 cos of x. We divide and multiply by 2. This is 2 root 3 by 2. Let's say this is cos of, this is 30 degrees, and we put 1 by 2 as sine of 30 degrees. So this is 2 times sin x into cos 30 minus, this is cos x into sin 30. That's 2 times sin a cos b minus cos a sin b. This is sin of a minus b, x minus 30 degrees, or 2 times sin of x minus pi by 6. So this is how we convert an expression containing sin x and cos x to sine only. Now to find maximum and minimum value of expression, sine of x or sine of anything, this is maximum value of plus 1, minimum value is minus 1. range of values is minus 1 to plus 1. Similarly, this also belongs to minus 1 to plus 1. So this sine of x minus pi by 6, this is lying between minus 1 and plus 1. And what do we want? We want value of 2 times sine, so that's multiplying throughout by 2. This is x minus pi by 6 less than equal to 2. So minus 2, this is minimum value, this is minimum value, and plus 2, this is the maximum value. Next question, we are given values of cos A and cos B. Also given that A and B lie between 3 pi by 2, that is 270 degrees, and 2 pi, that is 360 degrees. That means A and B both lie in the fourth quadrant. We have to find value of cos of A plus B. Cos of A plus B is cos A cos B, and minus sine is sine B. We have values of cos A and cos B. We need values of sine A and sine B. So using identities, sine square of A as plus minus root of 1 minus cos square of A. This is plus minus root of 1 minus 16 by 25, or this is plus minus 3 by 5. This is minus 3 by 5. This is minus 3 by 5 because angle A is in fourth quadrant. Similarly, we can find out sine square of B as 1 minus cos square of B. 1 minus 144 upon 169, that's 25 upon 169. Or sine of B, this will be plus minus 5 by 13. We take minus 5 by 13. Again, this is in fourth quadrant. Now we substitute values of cos A, cos B. So we need value of cos of A plus B. Cos of A plus B is cos A 4 by 5 into cos B 12 by 13 minus sine A minus 3 by 5 into sine B minus 5 by 13. This is 48 upon 65 minus 15 upon 65. 3 times minus sign means negative sign. So that's 33 upon 65. Question, we have to prove tan 13x minus tan 9x minus tan 4x is equal to tan 13x into tan 9x into tan of 4x. So we have 3 tans. Angles are 13x, 9x and 4x. We write 13x as 9x plus 4x. We start from the angles, then taking tan on both sides. This is tan of 9x plus 4x. Tan A plus B, this is tan A plus tan B upon 1 minus tan A into tan B. 9x into tan of 4x. Now cross multiplying, tan 13x into 1 minus tan 13x into tan 9x into tan 4x. This is tan 9x plus tan 4x. And shifting these two terms to the left hand side and this one to the right hand side, we get the answer. Tan 13x minus tan 9x minus tan 4x. This is equal to tan of 13x into tan of 9x into tan of 4x. This is how we prove it. We'll start with, from the right hand side. This is cos square of A minus B. That's cos A minus B into cos of A minus B. This term also has cos of A minus B. So I am writing next to this 2 cos A minus B into cos A cos B. And then this term, third term, cos square of B. Taking cos of A minus B common is cos of A minus B minus this is 2 cos A cos B and plus outside cos square of B. This is cos of A minus B. Cos of A minus B, expanding this is cos A cos B and plus sin A sin B minus 2 cos A cos B plus cos square of B. This is cos of A minus B taking minus sign common, this is cos A cos B minus sin A sin B. So let's write cos A cos B minus sin A sin B plus cos square of B. This is cos of A minus B. This is minus of cos A cos B minus sin A sin B is cos of A plus B, plus this is cos square B minus this is cos A plus B into cos of A minus B plus cos square of B. This is minus cos A plus B and cos A minus B is cos square A minus sin square B plus this is cos square of B. This is minus cos square A plus sin square B and plus cos square B. Sin square B plus cos square B, that is 1, minus this is cos square of A, and 1 minus cos square of A is sin square of A, same as to prove the next result. We start from left hand side. Sin A plus B, this is sin A cos B plus cos A sin B, and sin A minus B, this is sin A cos B minus cos A sin B, divided by cos of A plus B is cos A cos B minus sin A sin B, and cos of A minus B, that's cos A cos B and plus sin A sin B. Now this will cancel out, this will cancel out. Sin A cos B plus sin A cos B is 2 sin A cos B, and upon it's 2 cos A cos B. So we cancel out 2, cancel out cos B, sin A upon cos A, this is tan A. This is what we wanted to prove. The next one, sin of alpha plus beta is given 1, sin alpha minus beta is 1 by 2. Both alpha beta, they are in first quadrant, 0 to 90 degrees. So alpha plus beta, this is equal to 90 degrees. Alpha minus beta, sin 1 by 2 is sin of 30 degrees. So alpha minus beta is 30 degrees. Solving these, adding first of all, 2 alpha is 120 degrees or alpha is 60 degrees. Substituting value of alpha in the first, beta is 30 degrees. Now tan alpha plus 2 beta, this will be tan of alpha is 60 plus 2 times beta. This is tan of 120 degrees, which is tan 180 minus 60. Tan 180 minus theta is minus tan theta. Minus tan 60 means minus root 3. The second value, that is for tan of 2 alpha plus beta. 2 alpha is 120 plus beta is 30. So this is tan of 150 degrees, which is tan 180 minus 30. This is minus tan of 30 degrees. This is minus 1 by root 3. This is how you got the answer.